Hello. Welcome to my channel, and this is Aiken Network Studio. You're welcome once more, and I'll be taking you through the journey of the CCNA exam. So, I want to talk a little bit slow when I'm trying to present my videos, but it depends on your preference that you want to watch this video with. Um, you might prefer to forward this by 10 seconds. Depends on what you want. Some people love to watch it slow and follow step by step, while some people would love to make it faster. So that's the reason why you've got a speed that you can actually adjust that. So again, if you make it here, then I would really want you to subscribe to this channel because as we go through this journey, there's going to be more videos coming, which is going to be of benefit to you. So if you like and subscribe, that's going to encourage me to do more video regarding this course. So we're going to start now. So this is first you're going to have on your screen, which is the CCNA curriculum. We have network fundamental, we have network access, we have IP connectivity, and lots more. So we will be focusing on the IP connectivity parts this morning because I believe you could go through the network fundamentals by yourself, the network access as well. So, well, this is not challenging, but I just think I could put you through this part of the course. So, we will be going through this to interpret components of routing table, the routing protocol, the prefix, the network mask, next up, administrative distance, the metric, and the gateway of last resort. So this is going to be for some next videos, and that's the reason why I told you to subscribe. So straight to the point, we will be using a packet tracer. So I believe if you're actually on this video, you should have some knowledge about packet tracer and how to arrange devices on packet tracer. So and I will quickly go through this with you. So we have types of routing. We have the static routing and the dynamic routing. The static routing, obviously by the definition, is what you have to manually input into the routing table. And if it's not static, then it's going to be dynamic. So we have these types of dynamic routing, the RIP, EIGRP, which is the Enhanced Interior Gateway Routing Protocol, Open Short Path First, OSPF, and BGP, Border Gateway Protocol. We will not be talking about BGP in this lesson because it's not required for the CCNA. So we have distance vector routing versus link state routing. So I just want you to know what these things mean. Distance vector routing, the bandwidth required is less due to the local sharing, small packets, and no flooding, because this mostly depends on the next up and the neighbor. So in this case, it's actually works with the distance, the number of hops between the source and the destination. So this is how it works. So the bandwidth required is less. So it's actually being shared locally. So based on local knowledge, since it updates table based on information from neighbors. So yeah, and another one is it makes use of Bell-Manford algorithm. Like I said, I'm not going to explain Bell-Manford algorithm. It's just some kind of formula for a distance vector to choose a path to choose a route to go to the destination. So just know if a question comes out of CCNA, it's just going to tell you what algorithm or what kind of metric does RIP used. And when you know that RIP is actually a distance vector routing, you could answer the question by saying Bell-Manford algorithm. And distance vector-based routing decide the shortest path based on the local view of the neighbor of a given router. So that means what you have next to you. So mostly number of hops to destination, right? So it converges slowly, and the example includes the RIP. So the link states type of routing is the bandwidth required is more due to flooding and sending of large link state packets. This is the situation where you're forming adjacency with numerous router sharing the same autonomous number. So OSPF is actually one of these routing protocol that when you are in the same um, area, then you float the packets all over the area. Uh, this actually could result in large packets. So based on global knowledge, it has the knowledge about the entire network. So you could know how um, CPU intensive that's going to be as well. But it's actually also very beneficial uh, in some kind of design, which is enterprise design. So it chooses the best route using the predefined criterion. So yeah, these are, a whole lot of metrics all put together before it's going to choose the path to go through to the destination. So unlike the distance vector that uses the Bellman-Ford algorithm, yes, the link state uses the Dijkstra algorithm. So you can go look up these algorithms and you'll find more information. Because we are actually having this lecture for a lab, I just want to go through all this as quick as possible. So it converges faster, and OSPF and ISIS, which is intermediate system to intermediate system, are examples of link states. We will not be talking about this. This is not even CCNP. Could be CCNP, but it's not really. So, but this is what we're going to be talking about maybe in the later lessons, not today. So, routing protocols are said by, the curriculum we're following. So it's asking us to describe prefix and also to describe network mask, and this I've highlighted. So we're starting with the routing protocol code. So the routing protocol code, I already get a snapshot of an output from a router, which you're still gonna see that when we're working on the lab. So this is C, which is connected. S means static. Connected means directly connected and the administrative distance of 0. Static has an administrative distance of 1. You're still going to see this in the later slide. R means RIP, administrative distance of 120. We don't need this. BGP, it's administrative distance of 170, which is the external, and the EIGRP has administrative distance of 90. External EIGRP is not needed at this moment, and the whole rest here are not needed as well. So this is just a quick overview of what it's the routing protocol code. Yeah, so exactly what I already said. So yeah, so when we're done with this course, I will quickly get you through some question and answers that you should be expecting on. You might be expecting on the CCNA, something very related to this. I don't say it's gonna be the same, but based on the questions that we do have, to prepare for this exam, I will just go through a little bit of them, which is related to routing. So now I have to show you this. This is the topology we're gonna be using, but I already added one more router for the purpose of showing a routing instance. One of the questions talked about routing instance. So that's why I'm adding this one more router, and you will see that on the lab. So I think this should be all good. So let's jump straight away into the packet tracer. Thank you. So this is the lab. Um, yes, so we're just gonna be going straight away into the lab, uh, just due to the time constraint. So you have this, then pause it and try to create your lab. Get your routers from here and be sure that you're using between two devices that are the same. You have to use the crossover cable, and for different devices you have to use the straight through cable. Yeah, so now I'm going to start. These computers are already configured with IP addresses, but I will show you how to do that. So now we'll follow these steps. Turn on the interfaces. So that's what I'm doing right now. Give me a moment. So I might be, my side, my point of focus might be different on the video. So I might be, I'm just looking at the screen that I'm actually working on. So if I'm not concentrating on the camera, it doesn't mean I'm not concentrating. So config tab, no shot. Yeah. So sorry, interface GI. You have to see they actually manually occupy. I've configured that before. So let's put an IP address into this. So as you can see, the interface GI0/0 is this one. You can always do this. And this is the second one, 0/1. So this is going to be a point-to-point address /30. Sorry, I didn't put the interface there. Interface GI 0/0. We'll go to exit, interface GI 0/1, IP address 192.168.10.1 in this case. So this is going to be the gateway address. So you should know how we calculated this to be 0 because it's /24, right? So that is complete, We do not have anything else after the third octet, right? So we already had a no shot, exit, show IP interface brief, do show IP interface brief if you're in the config mode. So you can see that. So that shows that we have that configured, and we have to go to the next one. Yeah. So enable config tab, interface GI 0/0, IP address .1.2. So it's a point-to-point address. No shots. Maybe if it's not shot already. So interface GI 0/1. No shot. IP address. You might not be seeing anything coming up because I already unshot those interfaces. .20.1. Exit. Now this last one should be, later, but I just want to get everything set. Interface GI 0/ maybe 0. Let's check that quickly. 0/0. Yes, so on this, there's one more we did not do. Interface GI 0/2. Good. So, and you can always save if you want, but you should always save anyway for you to get back there. So, you see, this is already done. This is done. Right, what we needed is done, and this. Good. So now we got done with all this. Now we have to go back to um, what we need to do. This configure IP addresses, configure static routing. So we need to configure static routing on this and this. This is a third one. We can configure static routing as well. At some point we will, but we have to configure on these two IP address. So config tab. This is how to configure static route. So when you see this, before we do that, I'm going to show you something. Don't be confused about the DO. It's just when you're not, you know, in a mode for you to see the route, then you do that. You can see we already have 1.0 routes as connected, and we already have 10 as connected. When we want to reach out to this and this, we have to have the route on the routing table. So we have to bring 20 over here, and we use this as the transport system. This is the next up, and this is the next up. So let's do that. IP route, destination prefix, 20.0, right, 245.245.245.0, right. So now next up, forwarding router's address. That's what it is. You cannot put your your the IP address on the router you actually on. You can't put that because it's not gonna let you do it. Let's do it. .1. Wow. .1.1. You say no. Invalid next up address. So you have to put 2 there, which is actually the next up address, right? So you can also try to do one more thing I didn't do yet. Try to get connectivity at least to the next up. Ping 1.2, right? You should be able to get connectivity, but you can ping across to the next router because it's not going to work. There is nothing like that, right? So anyway, show IP routes. We've just configured static routing on this router, yeah? Show IP route. Now we have a static routing of 20. So we could actually try to ping through and see. Right, we're already reaching through 20, but we cannot reach back to 10 because this router 2 does not have route to 10. You see, there is nothing like 10 here for now. 1, 2, and 20. So ping 192.168.10.1 would not work. Yes. So IP address config, sorry, IP route 192.168.10.0. So we know we have to put the next stop. End. So it should work now. Show IP routes. Now we have 20, right? So ping from here now, we have 10 rather. So ping 192.168. The previous ping that did not work, this is the previous ping that did not work. Right, do it now. It works. So that shows that we've done the configuring of static routing. So I will tell you why we need a third part. I will do that quickly when we're there. So configure basic EIGRP. It's for the purpose of a question we have when we're done with this class. So configure basic EIGRP Let's do it on router, between router. It says 4 here, so let's do 4 and 5. Right. Well, yeah. So between these two. So if you don't know how to configure EIGRP, there's not a problem. But if you know, that's cool. It's just the basic one that we're gonna do here. You just say router EIGRP, the autonomous system, just put 1 for simplicity. So you have to turn on the routing on this router. So network 192.168.2.0 again. So now there's going to be something different from what we did before. This is going to be wildcard bits. This is not going to be um, the subnet mask. So if you don't know how to calculate a wildcard, I might not be able to say here right now, but I will just tell you, but I will not go into details, right? Let me see if I can use this to do it because I don't want to go out from here. So wildcard mask is like this. Let's say subnet mask says 255.255. This is always a complete, you have to use this as a reference. Right. Yeah, this is the O subnet mask. So we can say this is equals to Y, right? Equals to Y, yeah, to Y. So whenever you want to calculate any subnet mask, what you do is you check what you have as a subnet mask for what is in question. So let's say subnet mask in question equals X. So the formula for getting the wild card is Y minus X. That's all. It's as simple. So in this case, X equals 255.255.255.252. So now Y minus X equals 255, 255, 255, 255, 255, 255, 255. So you have to minus it. That's what you need to do here. Minus. And what does that gives you? Gives you 0.0.0.3. That's all you need to make this configuration work. So that's how to calculate that. And that could also be a question in the CCNA for you. So that's it. You already network that. And I will also want to advertise what network. Now I want to advertise a network on this router. Do show IP interface brief. You have 2 networks connected on this router, as you can see. 3. We have 3, right? And this is what we're using to form the EIGRP. So you don't need to advertise this one, but you would need to advertise this one and this one. So that's what we'll call network 192.168.20.0. But for these, remember it's /24. For you to see that, you can do show run interface GI0/1. Do show run interface GI0/1. Okay, show run. Let's do it perfectly. Interface GI0/1. It doesn't show run. Oh, sorry. Maybe this is some packet tracer kind of thing. But let's show run in total. This is what it can do, right? Couldn't do the advanced kind of thing. So you can see that, whoa, there is a mistake here. I really need to correct this one. It should not be 252. It should be should be 0. Yeah. So that was nice. We checked then. Please correct yours if you have done any mistake there. It's not like a big mistake, but we could have a whole lot of um, devices connected to this, and if you cannot tell the router you have two usable IP addresses, then the rest of the devices will not connect. So that's why we need to do that. Uh, Give me 1 second. Sorry, you have to put .1 is an IP address. So good. It's not for network. I'm not actually putting a network. I'm putting an IP address. So put this in, then we should be fine. So now let's continue with the configuration of the that. So show run, so you can see what you've just done. Yeah, so that's right now. This is what I want. So router EIGRP1. Yeah, into the router configuration mode. So now you will say network 192.168.20.0. This is a network. That's why it's called network statement, right? So now this you have to say 0.0.0.255 because this is /24. Look at it, 255, 255, 255, and when you put that here, you have to have 240.0.0.255 because this is going to be 0, right? So that's how we network that. So we're going to network the additional 1.0. So in this case, this is 252. So 0.0.0. You can put, 245, but sometimes we have to have a good practice. There is no reason to, put in IP address network that we don't need. Because at some point also on CCNA, you'll be getting questions about an engineer who has to assign number of devices and you want it to be as exact as possible. So this is how you get to know all this. So done, then we have to form the adjacency on this router. We'll do almost the same thing, router EIGRP1. So network 192.168.2.0.3. So immediately an adjacency is formed. So we'll also want to just announce the network we have on this, which is 30.0. You just need to announce to network what you have connected on this router. However, let's confirm as well if we didn't do any error on this interface. So let's see if it's .2 0/1 is not configured yet anyway, so I do that. Yes, it's not. As you can see, this is 0/1. Let's I remember when I was doing my CCNA exam, um, show run is a very vital tool for you to, when you want to do something and you're not sure what's going on, just do the show run, see the configuration, and that can help you a lot. So yeah, I think we should be good with this, but there is one more thing that's not going to work, which we're going to try later on. So now you should be able to ping. Let me show you how to put in an IP address quickly. You go to desktop and you go to this. I already have it there. You put what you want to put, and this is the gateway address. It's always going to be the gateway, the address you configured on this interface going to the router. This is a local area network, so you must have a gateway. So now let's go and test connectivity. It says this, check routing table. Okay, good. Let's do that first before checking connectivity. So now show IP routes for us to be able to go through what is being written on the question. So this is D, as you can see, EIGRP, C connected, L is local, right, like the IP address itself. and D and C, yeah? It's kind of bringing all these things together, right? So now let's quickly test connectivity. I also have this configured with 10 already. Yeah, so you go to run. Now ping 192.168.10.1. Go on. So ping, there's one thing you're not going to be able to ping, I will tell you. Go to 20.2. Let's see. Yeah, it's getting it already. That's some app request. Sometimes you have to send some app request. Yes, working. So now you cannot ping 30. Oh, you can ping. So yes, destination host not reachable because of course this guy does not, understand how to handle traffic that that doesn't have in its routing table. This is getting a little bit advanced, but still CCNA. No, sorry. Right. So you see, so there is no 30 and doesn't know what to do about it. So we just had this now configure. Oh, I already said configure static routing, but I didn't do it. Yes, see, this is it. And also on our curriculum, if we check on our curriculum here, look, we were actually talking about default routes. Okay, yeah, static routing, I have to put default routes. So network mask, prefix, we know what prefix is now. Network mask, we know what it is. Next up, we know what it is. Administrative distance. Okay, so what I'm gonna do here is I would have to open one of the router again. Yes, and I would open this side by side. So this is what the curriculum is telling you. We're already done with this. You have to understand what this stuff means. And the prefix is this, which we already explained, which is, you know, /30. Network mask is the 255, the 255, the 255, the 232. For this one, you guys know that already. For 24, you know what it was. The next up is gonna be this one, the next up address. This is the next up address, 2.1, as you can see. It depends on whatever router we are on. So this is 2.2 and this is 2.1. So that's the next up for that. So administrative distance, you can see this is administrative distance. This is for EIGRP, it's 90. And for static routes, connected is 0. You might not see that here. So for static routes, it's 0. It's 1, sorry. So that's about that. Let me show you again. So now the metric is actually this calculation you have here. The metric is this calculation you're having here. Let me show the one that has EIGRP. So this is the metric, 90 over 5376. You have to know how to calculate this, but it's not for this course. Just know this is what is called metric. This is how the metric was calculated for this route to make it to the routing table. So this is basically the administrative distance. This is what you need to, know at this time, and also know that this is the metric. So that's about that. And the default routes. So gateway of last resort. So gateway of last resort, we have to configure that here. This is where we need that for now because we're going to be sending routes right? That we don't know what source it is, because this has all the routes for the whole network. This router has all the routes for the whole network. This router does not have all the routes for the whole network, and this one does not have all the routes for the whole network. So for now, when this does not have, the route, what do you do? So you have to send it out of this interface to the next hop. So that's what we're going to configure here real quick. 0.0.0.0 means whole network, everything that you don't know, everything that exists, or everything that exists between 0.0.0.0 and the whole of /32. That's what it's this. So what's our next step? Good. So now you were not previously able to ping 30, if you remember. Then from here we cannot ping 30 here. So we should be able to ping 30 now, hopefully. So you see. But there's something called trace ads. Let me do that. Trace ads. So you see, it's sending, it sends this stuff. Yeah, it's still not actually complete because there's one more thing I'm gonna do, like I told you earlier, right? It's sending it out before we're having this. Yeah, but now we don't have that anymore. Now you cannot see anything because it's already sending what it has to send, but it couldn't get, request timeouts because it's not getting a response, but it's able to send it out of the router. So the last thing we need to do is, it got through here, as you can see, to 1.2. 1.2 sent it to him, but you will not see that. But it's been dropped because he doesn't have a route. But if I've also configured static route here, it might send it back to him. But there is no reason for us to do that. I would rather, if I configure default route, I mean, so I will configure a static route on this router. IP route, as you can see, it does not have 10, right? It has all but not 10. Dot 10.0. That's the whole network of 10. All networks of 10, then 168.2.2. Right, that's 1, sorry. So that's exactly what we need to make it work. So now if you try to do the same again, I'm gonna do a trace sat again. It's just for you to know the route. I know packet tracer has a different thing, but I want you to get used to the best method, because at some point you might not be using this packet tracer. You might use GNS3, you might use EVNG. So you have to get used to this way of seeing traffic routes. Now you can see it went through. So now he already knows how to get to this. You see? So everything else in that will be working, right? Provided this has been configured with 30.2. Well, let's see. Yeah, it was just sending some app requests. Alternatively, you can do this. I don't do that nowadays. So you can just do this. And you're gonna check here, successful. And you can do some simulation if you want. I don't really do this that much. You say real time and our simulation, and you play it. And I want to forward it. You send it back. Yes, that's it. All right. So that's about that. So now, or we have to now start checking. Let's see if we've covered what we need to cover real quick. Yes, everything has been covered. Right. So next lesson, we'll be checking all these ones. But before we leave, it's time for question and answer. Right. Let's just go to question and answer. Be sure that these are very model questions that you might possibly get, something very related to these questions. So, try to pause your video and, I was answering some of the questions already, so well, I don't want you to see the answers, but I believe you've seen it, but it doesn't matter. So which attribute does a router use to select the best path when two or more different routes to the same destination exist from two different routing protocol? Do algorithm is just something about um, EIGRP it's nothing to do with this because we're talking about two more different routes from the same destination. The metric is actually what goes next after the administrative distance. Because if the administrative distance, if one is lesser than the other, the lesser one is going to make it to the routing table anyway. So up count has nothing to do with this. So the answer here is administrative distance. So also pause this. When a floating route is configured, which action ensures that the backup route is used when the primary route fails? In this kind of topology, we will not do that because if we have, let's say, another route coming out of this router to a different router here, for example, and here, then let's say this route goes down, then it might use the second one. And we have to configure a backup route for it. Let's say, for example, let's say I have this. Now, if you do this, it's going to ask you distance. That's the administrative distance. If you put 1 here, that's not good because the static route has 1. So you put any other number, 2 or 3 or 4 is going to be a backup kind of route. So if the primary one fails, then the secondary takes over. So it has to be higher than the primary uh, administrative distance, right? If it's lesser, then it's going to take over as primary. You can, if you put 0, you see there's no 0 there. You can always start from 1, as you can see, because 0 is for connected. So let's go back quickly. So the floating distance must have a higher administrative distance than the primary route, so it's used as a backup. That's exactly the answer. In the next one, number 3, yeah, okay, the answer is already shown. There's no point. If a notice message is sent to a syslog server, which event has occurred? Most of the time, a network device has restarted. You might not really find that as a notice level. That could have been something more than a notice level because you have to understand what level it is. We have different types of level. You can go read that up. So notice level is actually not what you get for um, a network device as restricted. And ARP inspection has failed. That's so another kind of level. So, but a routing instance has flapped, you know, uh, that is actually a notice kind of level. Number 4, yeah. Which route does the router installs into its routing table? I'm going to teach you something later on. It's called longest prefix. It's part of what we need to check here. Let me just scroll up real quick. As you can see, this is what we're going to be checking this next time. So that's why you have to watch this video to the end. And also, if you're really serious for this exam, all materials should be important to you. So you could at this point subscribe to this video because we're going to be talking about longest prefix and administrative distance and routing protocol metric in our next video because these questions really do come in the CCNA exam. So, so the thing is, what do you think is going to make you choose to the routing table with what we see? The first thing is the longest prefix. This is the longest prefix here. You first have to choose this one, and they're saying choose 2. So you need one more to choose. So when you're done with the one with the longest prefix now, then you have to look at the administrative distance of the route. RIP, I told you already has 120, OSPF has 110. And OSPF is actually going to be installed before these two routes because of the administrative distance, and it's on the /30, /30, /30, /30, and /16 will not be, we not make it there now because we have /30, which is actually OSPF. So it should be these two. We must send all traffic without matching routing table to this. So what do you do? Which configuration accomplishes this task? Must send all traffic without a matching route, means there's no route to that network. And that's what we already done here by having a static route. So when you have a static route, a default route rather, then it's going to send the traffic to the next hop. And we have this almost exactly. So that's about that. So this concludes the video for this part, and please subscribe for next video. So you can always, click on the thumbnails on your screen in order to subscribe to this channel for the next video. Yes. So thank you so much for watching, and I remain Aiken, and thank you. Like and subscribe for me to encourage me to continue doing this. Have a good day. Thank you.